Right, so the next thing in relation to pseudocode or programming in the first place is how we represent solutions using shapes. Now, this is known as flowcharts, so that's what we're going to be looking at now. We're going to be looking at the standard shapes as well as how they can be put together in an exam situation. Okay, so flowcharts, if you've done any computer science at Key Stage 3 or even sometimes in design technology, this is covered. But anyways, we're going to run through what the content here is. Right, so a start or stop is this shape here. So it's like a rectangle but with rounded edges. Okay, so that will be always the beginning of every flowchart and also the end of every flowchart. Okay, remember a flowchart really is a representation of a solution. So a bit like how we have here a program that we looked at previously, how we saw other pseudocodes. In fact, I can't show you one now, but how we saw other pseudocodes earlier on, we would now represent that pseudocode solution using shapes. Okay, so we will always start with a start and a finish. A process is effectively an instruction or a command. Really, in other words, when something needs to take place, when something needs to happen. Okay, so if you say, for example, you're going to calculate something, that's a process. You're going to, I don't know, boil a kettle, that's a process. You're going to take a walk somewhere, that's a process, so an action that's taking place. Right, a decision is a bit like an if statement that we'll be looking at. So we want to determine if a particular thing is true, then we take a particular action. Now, when we're making decisions in flowcharts, we would have a yes or a no coming out of that decision. Okay, I'll show you an example of this soon, but we will have this shape, this diamond shape, and a yes or a no depending on the condition being met. What I didn't say earlier on is this process is a rectangle shape. Okay. Now the input or output. We mentioned earlier on what inputs are. So this is when the user enters something into the program, and an output is when something comes out of it. Interestingly, both of them use the same shape. Okay, so it's this parallelogram shape, and the idea is an input, data received by a computer, and the output is a signal or data sent from the computer. So once we've done our processing, we can use the output shape as well. Now connectors, we are not going to focus on in this specification. You would not be asked about connectors, but just the idea that they are used to jump from one point in the sequence to another. So I would say please do not worry about connectors. One thing you do need to worry about is the direction of the flow. Now, you would always have arrows connecting up the flow chart. Now, those arrows needs to, you can't just put lines, it needs to show the way that data or instruction is flowing. And that's why it's called a flow chart. So you need to show directional arrows. Now, having said all of that, let's then put it into context of an exam question. So I'll show you an exam question. So here is an extract of a question. So it said June 2017, question number 2A. Okay, so it gives us a condition, it gives us a scenario here. The Sally's requirements for the program are given below. So it says the number of bank accounts to be compared is entered and stored as a variable. So it says here something is entered and then stored. So that means because it's been entered, we would need to use an input. Okay, so because here they told us to create a flowchart for that particular requirement. So we need to use a flowchart to represent all of this. So effectively here's one I made earlier from the mark scheme here. So remember what we said earlier on. Every flowchart has the start. So there's the start. And in this case we said here that the bank account is entered. So they've used a variable name called bank account, and we notice that we're using the input shape, yeah, and then we're saying bank account, which is a variable, equals input the number of bank accounts. So effectively just saying to the person, enter the number of bank accounts that we want to compare. The next point is the money to be saved is entered. Again, the fact that it says entered sure you don't need to be told what shape that would be. Okay, but just as a reference, just go back to it. Because it's entered, yeah, data is inputted, we'll be using this shape. So let's go back and see if that's true. So again, we got the same shape here, and we're inputting the number of savings. Okay, so here it says enter the money to be saved. Okay, then the next thing says the interest rate is then entered and stored in a variable. So entered again, what shape is that going to be? A parallelogram, which is the input shape. So let's see if that's true. Again, rate, so you will get the mark for drawing this shape, and then writing a variable and inputting what they've said for you to input. Okay, hopefully you're following me so far. Then it says the interest is calculated. Now, if something is calculated, we're doing something, we're taking an action. Okay, so it's calculated by dividing the money to be saved, which is what we entered here, by 100, and then multiplying by the interest rate, which we've also taken in from here. So effectively, in this case, the key thing here is we're calculating something. So what would that be? Again, just to go back to our point here, we're doing something, so we're taking an instruction. That will be a process. So let's go back to the mark scheme, and we notice the process shape is here. So we're saying interest is based on the savings divided by the 100 times by that. Okay, so this particular, what's written in here, is going to be specific to every scenario. The key point I'm trying to get you to remember here is the shapes. Okay, so here we're using the process shape to indicate that we are doing something. All right, we're taking an action. Let's go back to the question. The total is calculated by adding the money to be saved to the interest. Again, we're calculating something. What I'm hoping you understand straight away, that that's again another process. So let's go back to here. We got then the total is equal to savings plus the interest. So what we worked out here, we're now adding it to the savings that we've took here previously. All right, now let's go back to the question. The total is then output. Again, going back to our thing here, output, which one of these is output? There. So we can see that output again is the same shape as the input one. So we just need to output what we worked out here. So if I go back to this one here, and you see we got output total, which was worked out here. All very straightforward so far, I like to hope. And then the last thing here says the program should loop for the entered number of bank accounts. Now, if this were to be pseudocode, you would write a loop like a for loop or a while loop. But in flowchart, a loop is very simple. You just draw a line going back to where they've indicated it needs to go back to. So it says the program should loop for the entered number of bank accounts. So we need to go back to where the person can enter the bank accounts, which is at the very top. So we're going to need to do, after our output, we're going to need to do a loop to the beginning of here. Now, so there is the loop going back. However, there is one thing here that we haven't covered, which is a decision being made. Now let's see why a decision is being made here. The program should loop for the entered number of bank accounts. Right, so based on the number of bank accounts, imagine I entered one bank account. I wanted to repeat this whole process many number of times. If I enter two number of bank accounts, it's going to need to repeat that number of times. If I enter three, it's going to need to repeat. So because we are checking based on a condition, we need to use a decision. So we are deciding how many times for it to go back. Hence why we've now got this here. So we're saying just make a decision until the bank account is equal to 0. If we've now finished all of the bank accounts, then we will be down to 0, in which case we will need to go back to the beginning and do this again. Whereas if it is not equal to 0, then if it is equal to 0, pardon me, we end. If it is not equal to 0, that means we've still got more to check. We're going to keep going back, going through the whole process, and keep looping and looping and looping. Whereas if it is equal to 0, then we end. Okay, so notice decision always has to have a no or a